Assalamualaikum and good evening to sir. Today we'll be presenting the RSA encryption techniques. My name is Azim bin Mohamad Ayub alongside my team members which are Ahmad Afiq bin Zaidi and Iman Nayli Sofiya binti Nur Azman. RSA encryption technique. The most secure method of encrypting data is the RSA algorithm, which uses public keys. Developed in 1978 by Rivers, Shamir and Edelman. Popular exponentials over integers, including prime numbers in a finite field, is done using the RSA algorithm. This method's usage of sufficiency large integers makes it challenging to solve. There are two sets of keys in its algorithm, which are private key and public key. For the encryption method, we use the plain text C, and the encryption number is 7 and 15. To cipher it, we must first raise the C value, which is to the power of the initial encryption number, which is 7. Next, we mod using the second number, which is 15. And then we do the calculation, and we get the answer ciphertext of 12 equal to L alphabet. For the decryption method of the ciphertext L, we use the decryption 1515. To cipher it, we must first raise the L value, which is to the power of the initial encryption number, which is 15. And then we mod using the second number, which is 15. And we do the calculation and get the answer of plain text 3 equals to the C letter.
Hello, my name is Ahmad Zaidi, and I would like to explain about the generating keys for RSA encryption. So to get the keys, we need to first take two prime numbers. So for our example, we use P equals to 3 and Q equals to 5. Next, we need to find the N, which is P times Q. So for our N, we will get 15, which is 3 times 5. So this N will be our mod number. Next, we need to find the coprime number of n. So we will be using the formula p minus 1 and q minus 1. When we calculate, we will get 2 times 4, which is equals to 8. So the coprime number of n is 8. To double check the number of 8, so we need to list from number 1 until 15 and see which can be divided by 3 and 5. So after we done that, we will get coprime n equals to 1, 2, 4, 7, 8, 11, 13, and 14, which is the total number of that is 8. So now we need to find the choosing the E, which is for our key for encryption. So E will be used for encryption. Now to find E, we need to follow these few rules. So the first rules is E must be bigger than 1 and less than coprime of n, and also coprime with n and coprime of n. So for our example, we use 1 is bigger than 1 is smaller than E and must be smaller than 8. Now this leaves us with 2, 3, 4, 5, 6, and 7. Now we need also to follow the second rules, which it must be coprime with n and coprime of n. The number that we leave us is 7. So for E, the number we will use is 7. So the key for encryption is 7 and 15. Now we need to find the D key for decryption. D will be used for decryption. To find D, we need to follow these rules. The first rule is D times E bracket mod coprime of n must be equals to 1. So D, the value need to be equal to 1. So for our example, we use 7D mod 8. 7 is our encryption key and D is we need to find. The mod 8 is we get from our coprime of n. So for this one, we need to see the multiply of 7 to find the value that can get the remainder of 1 equals to 1, because 7 is our encryption. So by taking the examples, we can calculate. So 7 times 15 mod 8, we will get 105 mod 8, which is we get the remainder is 1. So for D, the number we use is 15, and the key for decryption is 15/15.
Hi, my name is Iman Nayli Sofiya, and I will be talking about the conclusion. So, strong encryption algorithm RSA has partially withstood the test of time. The security of RSA's public key crypto system, which enables digital signature and secure communication, is based in part on how challenging it is to factor huge integers. So, no one has so far seems to have succeeded in breaking the author's code, despite their invitation for everyone to try, whether by factorization methods or another method. So this has effectively validated RSA and will keep ensuring its security for as long as it resists similar intrusions throughout the time. The sole candidate for a trapdoor one-way permutation at the time appeared to be the RSA encryption mechanism. As factoring algorithms get more effective and computers become quicker, the average size of n must grow with time. In reality, another less secure but fastest algorithms key are frequently transmitted securely using RSA. Undoubtedly, as mathematicians continue to learn more in the areas of number theory and cryptanalysis, many more complex algorithms than RSA will be created. Thank you so much. That's all for me.